Today, I'll guide you through the installation and setup of NAOMI, an MLOps solution designed for deployment on Kubernetes clusters. Let's start with setting up the Kubernetes cluster. If you already have your own Kubernetes cluster, you can skip this step. We'll run the system installation script, which will automatically install MicroK8s, enable the necessary add-ons like DNS, storage, and ingress. If you use K3s Kubernetes cluster, we developed a script that helps with adjusting K3s to be compatible with NAOMI. Once our Kubernetes cluster is ready, we'll move on to step 2. Deploying the NAOMI AI or ML workflow system. You'll see a configuration file called values_example.yaml. This file contains all the settings you can customize for your deployment. Take a moment to review and adjust these settings according to your needs. It is important that you change the IP address in 3 places to your machine IP address. When you're ready, we'll use Helm to deploy the system. Please keep the application name short, no more than 4 characters, due to Kubernetes naming limitations. The system deployment takes some time. You can monitor the progress using kubectl tool. After deployment, you'll have access to several web-based dashboards. The Ray dashboard for monitoring your distributed computing tasks, the Flight console for managing workflows, the MinIO console for data storage, Grafana for system monitoring, and the MLOps for managing your AI models. On the screen you can see how these dashboards look once NAOMI is deployed. For running our example AI or ML workflows, such as quality of experience prediction, we'll need to prepare the environment. Our environment preparation script will install all the necessary requirements, create a Conda environment and connect the Flight workflow orchestrator to your cluster. If you are running the environment outside your cluster, the script will ask you to provide an IP address of NAOMI deployment. Now, let me show you how to run our quality of experience prediction example. This workflow is adapted from the ORAN software community AI or ML framework, making it a good example for telecommunications and network scenarios. First, we need to prepare our data. Let's look at the MinIO insert.py where we'll upload our training data. Again, we need to adjust the IP address as you can see on the screen. The data is uploaded to MinIO. This data contains various network metrics that we'll use to train our QoE prediction model. Now we'll launch the training workflow. We're using Flight to orchestrate this process, and we can specify parameters like batch size and dataset size to control our training. For example, we can start with a batch size of 10 to test the workflow. We just copy the command from NAOMI repository. As the workflow begins, you can monitor it in the Flight console. Let's watch the training progress across our dashboards. Flight showed direct acyclic graph of our workflow and the progress. Ray shows the progress of model training. The trained model is automatically deployed on Ray. NAOMI sets up an inference API endpoint. You can see the endpoint becoming active in the Ray dashboard. The model API endpoint is also automatically tested. The system has created a REST API endpoint where we can send network metrics and receive QoE predictions. Once the training is complete, the model is automatically registered in MLOps with all its parameters and metrics. And there you have it. You've just seen how NAOMI orchestrates a complete AI or ML workflow, from data preparation through training to deployment and monitoring. This same pattern can be applied to any AI or ML use case you might have.